Hello everyone, my name is Timothy Lee Grant. So today I am going to be trying to do a backtracking problem. So I did backtracking a very long time ago. I think that would be like 6 or 7 months ago, something like that. Studied backtracking and I can't remember exactly all of the ideas behind backtracking, but I am hoping that I'm going to be able to look at it and kind of refresh my memory, see if we're able to solve it. So let's try one. I'm going to close, or not close, but make myself a little bit smaller, and we're just going to pick the next closest medium. Okay, so that looks like it's this one. Iterator for culmination. Okay, so let's try it. Let's try it. Let's try it. Okay, this is a weird one. We have to create a class. Yeah, I don't like it. Okay. That's a hard. Here we go. Number 1593, split a string into the max number of unique substrings. Okay, so what am I saying right here? I need to split a string, so I'm going to be given a string, and I'm trying to find the maximum number of unique substrings. So it's kind of an optimization problem, right? I'm trying to maximize something, okay? And what am I trying? What is the condition? The condition is unique substring, okay? All right, so now let me read the problem. Given a string S, return the maximum number of unique substrings, okay, that can be given, or that the given string can be split into, okay? You can split string S into any list of non-empty substrings where the concatenation of the substring forms the original string. However, you must split the substrings such that all of them are unique. A substring is a continuous sequence of characters within a string. So we have this A, B, C, C, C. So I'm thinking before I look at the answer down here, I think what's going to happen is, let me just copy and paste that up here, right? Have it like this, okay? So I think this is going to be a substring. I think this is going to be a substring. I think this is going to be a substring, okay? Let's see, this will be a substring, but this is not a substring, and this is also not a substring because we already have a string of A right there. So then we'll have ABA, that's a substring, ABAB, that's a substring, and then ABABC, that's a substring, this is a substring, this is a substring, okay? Then I also am going to have here BA, that's a substring, BAB, that's a substring, this is a substring, okay? So then I can come here and say A, well, this is not a substring. AB, this is also not a substring. ABC, this is a substring because I don't have it yet. So I'm thinking, what can I do to be able to, and I'm even just talking through this, I saw that there's kind of a pattern. I start here and I add, is this a substring? Yes or no? Like, do I already have this in my, is it a previous substring that I've already seen before? And the answer is no, so I add it. And then I come here and I add this. So I see how I'm doing this, and then I move down here and say, is this a substring? Is this a substring? Is this? Okay, so that's my first note, is I kind of see a little bit of how the process is building out. Now the second question is, how can I check if I already have a substring? Now, okay, well, the question is, what data structure would be beneficial for that? a set is what I'm thinking. Unordered collection that allows me to simply look up in O of one time, like, hey, is this in my set? Yes or no? So I need, let's see, so I'll need a set. So my set, also, let's make sure that I was actually correct about this. So A, B, yep. C, yep. CC. Hold on. It's not asking how many substrings. It is saying the splitting, okay. Splitting like A, B, C, O. Hold on, that doesn't make any sense. Actually, one way to split minimally, or maximally, is like that. Okay, never mind. What I was explaining up here, that's not accurate, but now I have no idea what the... So why is ABA not a substring? Okay, that's one of my questions. I need to go back up and read the problem statement and try to understand why ABA is not a substring. Okay. So, given a string S, return the maximum number of unique substrings that the given string can be split into. I think this can be split into this substring. You can split string S into any list of non-empty substrings. Okay, the ABA is a non-empty substring, where the concatenation just means putting them together, of the substrings form the original string. However, you must, okay, so I think this is the condition that is not met, but I'm not, let's see, so if I take A, and I take B, and I take AB, and I take C, and I take CC, and I concatenate all of those together, I do get this. Okay. And if I take ABA, and then so if I take like AB, right? And then I can't take AB again. Okay. It's a weird condition. I'm not sure how exactly to deal with that right now. However, you must split the substrings such that all of them are unique, okay? Yeah. A substring is a continuous sequence of characters with a string. Okay, yeah, oof. One way to split maximally is A and B. So A is a substring, B is a substring, and if you concatenate them together, you do get this right here, okay? And now, AB is also a substring, and if you concatenate A and B and AB, you do get this, okay? And now C is a substring, okay? And then CC is a substring. And if you concatenate everything, you do get that. But, oh man, how am I going to actually go about doing this one? Is not valid as you have multiple. Okay. So if I come here and I look, I'm trying to maximize the number of unique substrings. So I should try to minimize the the length of each individual substring. So I still think I need a set, okay? Because I need some way of keeping track of which ones I'm adding in. Okay. How would backtracking help me with this? I remember backtracking is something about it is like a recursive function, and I'm adding things in and I'm taking things away, and then I'm checking conditions. But how does that work in here? Traverse something, I don't know, pass, and then return, like, max num equals to 0, and then I traverse s, and then I need to, this is going to be like recursive or something, right? So I need a base case in here. What if not word, and this is going to be word, okay, return something. What am I going to return? Man, I don't know. Return none? Return 0? Okay, now I want to do something here, right? Like, I don't know, a process? I don't even know what that means right now. And then recursively do something. So, left, or like, what was it, include? This one is going to be include it. Okay, so if I include it, and then we would have another one like don't include. Okay, so how do I do that? So not include is equal to traverse word So if I don't include it, I don't want to add whatever letter I'm considering. So I'm going to come here and I'm going to consider adding it or not adding it. Okay. But then how do I determine if it has already been, like, how do I determine that thing of like it's concatenated or not concatenated makes up the larger word? Is there some other data structure that I can use? Current word, I don't know, current word is going to be equal to an empty string. And then I'm going to say Huh. Okay. I also remember, yeah, something about I would have, for backtracking, I would have some variable that I would be adding to or taking away based off of each decision I was currently looking at. Um, so, what if I had, I don't know, left pointer and right pointer? I don't even know what I'm doing right now. And I said if current word dot append the word that I pass in sliced at start at left end at right, okay, is equal to s sliced at left to right. What I'm thinking about this is, like, let's say I start here and I pass in this entire thing, this entire word, and I might not even need this like word right there, which actually does mess this up, but we'll deal with that base case. Okay. So I'm going to traverse, and I'm going to traverse left is going to be at 0, right is also going to be at 0. And so then I'm going to consider adding this A. I'm going to consider adding it, or not consider. And so I'm going to say if the current word here added this letter here is equal to this string, this entire string between these two, which is just A. Actually, I might need to do right. Oh no, because this is inclusive, non-inclusive, something like that. I don't know. If this is the case, then what I can do is then I am allowed to try to include it. So then I'm going to say allowed to try to include it. So what follows from that? It means I do current word plus equals, maybe actually I need to do it like that, plus equals right, no, s indexed at right, now this is going to be s, that's not great. No, this should be current word. Okay. So then I add that letter in there. Oh man, I don't know what I'm doing. So I add that letter in there, okay. And then allowed to try to add it. Then what I can do is get rid of this recurse. I don't need that. This is the include it, and here's the don't include it. is left, right plus 1. This is wrong. This isn't. Okay. Yeah, I'm gonna look at the solutions. So, oops, solutions. Okay, let's now try to do the analysis part. Like, how did they do it? What did I trip up on? And try to understand the actual solution. Okay, so backtracking approach. We try to split the string at every possible position and maintain a set of substrings that we've already seen. So some of the questions that I have right now is, how are we going to keep track of if the substring is actually allowed? How do I even articulate that? When I'm considering adding a substring, how do I know if the concatenated version of that substring, based off of all of the other strings that I've added to the list, are in fact part of that substring, or of the larger string? I don't know. So we try to split the string at every possible position and maintain a set of substrings that we've already seen. If a new substring is not in the set, we add it to the set and continue exploring further splits. Maximizing the count. During the backtracking, we try to maximize the number of unique substrings, and once all possible splits are explored, we return to the maximum count. Okay, so number 1, start with an empty set to track substrings. Recursively try every possible split and check if the current substring has been used before. Okay. If it hasn't been used before, add it to the set recursively. Split the remaining part of the string. Keep track of the maximum number of unique substrings. Okay. So, backtrack, start and scene. So 2 parameters, start and scene. This function starts at index start and explores all possible substrings. Starting from the start, and explores all possible substrings, okay? For each possible substring from S of start to end, if it is not in scene set, we add it to the set and recursively check. Okay, so we are probably going to be moving the start over by 1 each time. Okay, so I'm going to try to take a little bit of notes just to organize my thoughts a little bit. So first thing is, it seems that we will be moving start over by 1 each time, and somehow this allows me to do what? To keep track of what I've added or not? If it's not seen, okay. We calculate the maximum number of unique substrings by maximizing the number of splits in each recursive call. After exploring the path, we backtrack by removing the substring from the set so that other possibilities can be explored. The base case is when start is equal to the end of the string. It means we've reached the end of the string and can't split further. Okay, so we return 0. Maximizing unique substrings. For each split, we try to maximize the number of splits and return the highest number of unique strings. So if we're at the end, we stop. Okay, that makes sense. Max splits equals 0. So we have this max split. The other thing that I'm noticing is that we didn't come up here and like have some variable in between here that we're keeping track of and dynamically changing each iteration. So we have a for loop within each backtrack. So for end in range, start plus 1. So from the start over by 1 and to the end. So we're going from like whatever, let's say that we start here and we're going all the way to the end. So actually we would be what, like that. Substring. There is a substring which is S of start to end. So like this. That's how we calculated a substring right here. Okay? And then the next iteration, it will be like that. Wait, no, like this. Because end is the one that's moving each time. Oh my gosh. Okay, so end is moving. And we're starting. So end is, so start, let's say I'm here, and then I'm going to add this one, okay? And then the next one, I'm going to add this one, and like that, okay? And then the next time I come here and I'm going to add that. Is that right? No, that's not right. If substring not in scene, add it, okay? Max splits equals the current max splits, or 1, because we've just added this one, right? Because it's not in scene, plus the recursive backtracking. Then we remove the current substring and keep going to the next one. So I need to spend a lot more time with this to try to understand what's going on, both with this problem and obviously I need to spend more time with backtracking in general, to understand how this concept is operating. Okay. So what is this going to give me? It's going to go from the next element. So let's say that I'm at start, and my start, I want to start here, right? It's going to be at 0. So I'm starting at my 0th one. And I'm going to start range from my start plus 1. And I'm going to the end. So this is going to evaluate to like 1, 2, 3, 4, 5, all the way to here. Then that's going to be my end. So my first one is going to be 1. So then I'm going from 0, right, to 1, which is just going to be this A. And then I'm doing this. Then I'm doing this, then I'm doing this, then I'm doing this, then I'm doing this, then I'm doing that. Okay? So that's what this line does. Creates a substring. Then I ask, is it in my scene? If it's not in my scene, I can proceed to process it. If it is in my scene, I can't add it because it's already in substring. Okay, so let's say it's not in scene. Then I add it to scene, this substring, okay? And then I say max split is either max split or, and I attach end, which would be like this as the start. Okay, so then I'm starting over by 1, which makes sense. It's just I'm trying to wrap my head around it. Like I can I'm at a 40% seeing it. So not even above 50%. I'm at like a 40%. But it feels like, okay, I can kind of understand what they're doing. And then they remove that substring and then try come up again. And then why? Okay, I need to spend a lot more time with these problems. So what I'm going to try to do is I'm going to continue to dig into this specific problem. So I'm going to not just like randomly go to a different problem. I think drilling in on a single problem, understanding a problem deeply and figuring out how it works is the best way to go. So I'm going to continue to look at this, and then in my next Leetcode video, I'm going to continue to try to solve this question. So if you are interested in that and want to subscribe to this channel, go ahead. If not, that's fine too. I hope everyone has a good rest of the day. My name is Timothy Lee Grant, and I will see you guys soon.